Teleoperation is a research topic focused on the extension of human capabilities to manipulate equipment remotely. It has many applications, and in this work, we focus on the mining scenario. An excavator is a big and hard-to-operate machine, and often the operator does not receive enough information about the environment to safely operate it, such as the force information from contact with a surface. In this work, we developed a framework for teleoperating a robotic arm. It works in real time and decreases the operator immersion using force feedback. Using a haptic device, the operator can control the remote arm and feel the haptic feedback from the interaction of the arm and remote environment. The arm movement is performed by a path planning in which points are defined in the space and a spline interpolator is used to produce a continuous motion. A gripper command was developed to allow the robotic arm to hold objects without forcing its engines. The haptic feedback was developed through the spring damper model. Thus, the operator can feel the variation in force applying in the arm. To identify the contact of the robotic arm with the objects, we use the load feedback of the motors. To visualize the arm movements, we created a virtual arm that follows the real ones.